Thank you for watching this project help video for lesson 24. I will help you answer each question in the project by providing step-by-step instructions using example problems. A good strategy might be to pause the video after each example and then work the corresponding problem in your project. Let's get started. When Goku battles a single opponent, the battles last for 2 hours, and when Goku battles multiple opponents, the battles last for 5 hours. Goku spent a total of 2,000 hours battling last year. He's a real warmonger. There were a total of 475 battles. All right, so the first question says here, define the variables in the situation and use the standard X and Y. All right, so this is the first step we always do, right, when we're given a problem like this. And then we're trying to write the system of equations that represents the situation, right, so that we can solve it and then solve the problem and figure out, how many battles Goku had. But first we have to define the variable. So let's look at our unknowns. So I'm going to go through our problem. And it says, let's write this for the first variable. When he battles a single opponent, the battles last for 2 hours. When he battles multiple, they last for 5. Then we know how many total hours he spent battling. And we know how many total battles there were. All right, so in this case, what we need to define a variable for, the X and the Y, is the number of battles. In this case, so X is going to be when Goku is battling a single opponent. So we're going to define that. So it's actually the number of battles. So it's going to be the number of single opponent battles. So because it's what we don't know here is how many battles there were of each. So that's what we're going to end up solving for in this project. Okay, so then if X was the number of single opponent battles, then Y is going to be the number of multiple opponent battles. So let me get rid of that first one so you can read it a little easier. All right, so right here, this was our X. Single opponent battles, that's X. And then multiple opponent battles, that's what we're going to call Y. And it's the number of multiple opponent battles. So is he fighting just one opponent or many of them? And forgive me if you can't read that, right, but it is here. So we're going to define those variables first, right? So X is the number of single opponent battles and Y is the number of multiple opponent battles. Okay, so now that we have that defined, we want to try to write an equation for this part in red, the first part. So we're going to end up writing equations to represent all the information in this problem scenario. Right, we're going to start with one at a time. So question 2 says just the top part here. So it says when Goku battles a single opponent, the battles last for 2 hours and multiple opponents for 5 hours, and that we know how many total hours he spent battling. So right away we know the total hours. So right there, that tells me that something is adding up or equaling to 2,000. And yeah, we know it's adding up to 2,000. It's all the hours that he spent battling single opponents and all the hours that he spent battling multiple opponents. So if X represents, remember, the number of single opponent battles, to figure out how many hours total he spent battling single opponents, I would take 2 times the number of single battles that he had, because that would give me the total number of hours that he spent battling opponents, single opponents. And then I would add that to the number of hours that he spent battling multiple opponents. So if Y represents the number of battles, right, for multiple opponents, then to figure out how many hours he spent, I would multiply that by 5 because each of those battles took 5 hours. And then notice that I sum up the single opponent battles and the multiple opponent battles. This would represent the hours for each. And we know that they add up to total 2,000 hours in this case. Right, so that's our first equation. And so moving on to question 3, of course, you can guess that it wants you to write the other equation. So now it's this part in red. It says there were a total of 475 battles, excuse me. Remember, X represented the number of single opponent battles. That was X. Multiple opponents was Y. So if there are a total of 475 battles, then if I just take X and add it with Y, right, we should total up to 475. So that's our second equation. So now we have two equations with two unknowns. And we're supposed to solve the systems of equations from the previous two examples. So we have to look back or rewrite them. Here I can write them real quick again. 2x plus 5y is equal to 2,000. That's one of our equations. And then the other one was just x plus y is equal to 475. Now in your project, it says, I don't care how you solve these. Use whatever method you want to solve it. So you could use substitution, you could use elimination, you could even graph them. All right, since we have the x and y together on one side, i.e. these lines are in standard form, I would choose elimination. I think that would be a little bit easier. But since we have technology, you could probably just graph them, right? Literally, you can go to www.desmos.com and type in both of your equations and see where the lines cross, and voila, you're done. All right, so that would be the real quick and easy way to do it. I'm going to go ahead and solve it algebraically just to give you another way to do it. All right, so I'm looking at these two equations. I'm going to use elimination since these equations are in standard form. And to me, it looks like I have to pick a variable to eliminate. They're both equally easy, but the 2 is a little smaller here, so why not eliminate the x? All right, so we learned in the last lesson how to do this. I'm going to choose to multiply the second equation here by -2, right? Because when I add the two equations together, I want those coefficients to be equal but opposite so that they eliminate. All right, so I'm going to go ahead and rewrite the second equation here once I do that, and I get that -2x minus 2y is equal to 475 times -2. That's going to be negative 900. No, 950. All right, so we didn't do anything to the top equation, so I'm going to rewrite it here to keep this organized. Right, now I can add my two equations together to eliminate x. So that I would get that 3y is equal to 2,000 plus a negative 950, or 2,000 minus 950, however you like to think about it. And we get that that is equal to negative 1050. All right, so the last step, of course, to solve for y would be to divide both sides by, sorry, positive 1050, divide both sides by 3. I don't know why I said negative 1050, right? Clearly this is a positive number because the 2000 is bigger. And so that we get that y is equal to 350. All right, but we're not done yet, right? We solved for one of the variables. We need both. It says solve the system. But the second part is easy, right? Usually all the work is getting the first variable. We solved it. This is a 3 right here. In case you're wondering, we're dividing both sides by 3. I can plug that back into either original equation, and the second one is obviously easier. So we're going to say that x plus 350, this is the back substitute part, is equal to 475. And now there's only one step to solve for x, right? We're going to use our inverse operation, subtract the 350 from both sides. And then we're going to go ahead and get that x is equal to 125. There, so now we've solved the system, right? When we write that as an ordered pair, if you graph this, if you opted to graph it, you would have seen that we had an intersection of the two lines at 125, comma 350. Right, so in the context of the problem, remember X was standing for number of single opponent battles. So there was 125 single opponent battles. And the Y here was representing the multiple opponent battles. So there were 350 multiple opponent battles. All right, so does the solution you found in the previous question seem to be viable in the context of the problem? Why or why not? Remember our solution here was 125 and 350. Is that viable? So they're kind of asking, does it make sense? And in this case, I would say that yes, it does make sense. Not only because I can check it in my original equations, by substituting in and seeing that I get a true statement, but that I know that the number of battles should be a positive number because I can't have a negative number of battles, right? I don't know what that would mean. So if one of my answers were negative, then I would go, no, it's not viable, right? It's not in the domain, right? That's what we say in math. Also, what if I got a decimal? So that might be kind of weird. If I got like 125.3 as an answer. Well, how do you have like zero point 0.3 of a fight? I mean, maybe you start and then quit. I don't know. But to me, it seems like my answer should be positive whole numbers. And in this case, since both of my answers for the number of single opponent battles and the number of multiple opponent battles are positive whole numbers, I'm going to say that yes, the solution is indeed viable. It makes sense in the context of the problem.